What evidence are scientists still looking for? Scientists continue searching for evidence to fill in holes in the existing Snowball Earth hypothesis. Scientists hypothesize that carbon dioxide emitted by ancient volcanoes may have triggered a greenhouse event, causing the ice sheets to melt. A band of water would form at the equator, and being darker than the surrounding ice, would absorb more energy from the sun than the ice would. This positive feedback loop would allow for the Snowball Earth to melt rapidly, most likely in less than 1 million years. Carbon dioxide levels must have been much higher than today's to initiate this global thawing, but scientists have found no evidence so far indicating that there was that much carbon dioxide in the atmosphere at the time. Scientists continue their search for geological evidence to support their theory of how the Snowball Earth thawed. In addition, scientists have found no evidence of a mass extinction, which would have occurred since most species would have not been able to survive under the harsh glacial conditions. Cryogenic organisms like red algae, which needed open water to survive, would have not been able to survive under thick ice. Scientists are currently working to uncover biological and geological evidence to help them understand the biota present during Snowball Earth. Finally, scientists have found evidence supporting the presence of surface water during the Cryogenian period, such as wave ripples in sandstone. This sort of evidence counters the Snowball Earth hypothesis, which states that the Earth was completely frozen during the Cryogenian period. Scientists are still trying to determine whether the Earth was indeed fully frozen or if a band of open ocean existed at the equator. How would evidence change the hypothesis? While a majority of the current evidence points to a completely frozen Snowball Earth, computer models suggest the possibility of a slushball Earth, which refers to a mostly frozen Earth with a band of thin, watery ice and open ocean at the equator. NASA's Earth System Model is a simulation allowing scientists to recreate the conditions of Earth nearly 1 billion years ago. Through this climate model, scientists found that warm ocean currents, like the present-day Gulf Stream, prevented a full global freeze-over. In addition, biologists are unable to figure out how cryogenian organisms would have survived Snowball Earth without this band of open water. In the event of a slushball Earth, photosynthetic organisms could have photosynthesized at the watery equator, with ice thin enough so light could shine through. While scientists do have some geological evidence supporting the slushball Earth model, such as rock formation showing that liquid water was present on Earth at the time, there is far more extensive and stronger evidence supporting the Snowball Earth hypothesis. If scientists were able to find more evidence to support the countering slushball Earth model, it would change the Snowball Earth hypothesis to include the equatorial band of open, slushy water. How does Snowball Earth relate to or help us understand our current climate crisis? Snowball Earth occurred almost 1 million years ago, but how does it help us learn about today? The theories explaining Snowball Earth could help form solutions to climate change. During Snowball Earth, volcanic eruptions that occurred are thought to have added sulfur particles into the atmosphere, blocking sunlight from entering the Earth and therefore cooling the planet. Scientists are working to see if they can make a similar substance artificially to cool the planet from its rising temperatures. Furthermore, the Snowball Earth hypothesis may provide clues to predict how the Earth would respond to extreme global warming. The theory on how Snowball Earth thawed states that after the accumulation of carbon dioxide in the atmosphere, Snowball Earth thawed rapidly in under 1 million years. The ice albedo feedback loop allowing for this rapid melting is similar to the conditions today, where the open water at the poles absorb more sunlight than surrounding ice and therefore cause even more melting. In summary, the Snowball Earth hypothesis is a theory proposing that the Earth was completely covered in ice several times in the past due to the disruption of the carbon cycle and the sun being fainter. Scientists were able to arrive at this theory through analyzing numerous lines of evidence, namely dropstones, glacial deposits, paleolatitude determination, isotope geochemistry, and banded iron formations. Further evidence that scientists are looking for include evidence of a huge spike in CO2 levels and proof of a mass extinction. A competing hypothesis for which some evidence exists is the slushball Earth hypothesis, which proposes that a majority of the Earth's surface was frozen over with liquid water around the equator. Finally, the relevance of this historic freeze-over lies in helping scientists create solutions to our current climate crisis and in understanding the triggers and effects of extreme climate change. That's the end of this video series. Thank you for watching.